do a test for proportions and then for means. I'm going to skip through this first part. It kind of just breaks down the little pieces and stuff like that. You know, when I taught it, I definitely went through all those pieces, but now I'm just going to go straight into an actual example. Alright, remember we're going to follow those 4 steps. So your first step is going to be to write out your hypotheses, and then if they don't give you a significance level, you can pick one. It'll make your life easier if you pick one in that first step. And then identify the parameters. Step 2, the plan step, choose your appropriate method, check your conditions. The next step, compute your test statistic, find your p-value. The last step, interpret your results in context. Again, if you wanted to use the test statistic formula, there's the formula. There's the possible directions for the p-value. Only use this test if the number of successes, here's the successes, n times p. Remember, in the hypothesis test, you're using p, not p hat, because you know what p is. And then n times 1 minus p are both at least 10, and the population is at least 10 times as large as the sample. Alright, so here we are back to those potato chips. So we already talked about this with the hypotheses. The null is that we're assuming the proportion is equal to 0.08. The alternative is that it's greater than that. So here it says in the problem what the significance level is. So since it's in the problem, you don't have to state it again. If it didn't say in the problem, you should definitely state, you know, I'm going to use the 0.1 significance level or whatever, the alpha equal 0.1 or 0.05, whatever one you pick. And then here's the parameter defined. So p is the actual proportion of potatoes. Alright, then I told you to write, you know, that I'm doing, you know, you're doing a 1 sample z-test for the population proportion, the random condition. So again, do your best work here on the AP exam, write things out. The supervisor took a random sample of 500 potatoes. The normal condition. So again, you can't just write n times p is greater than or equal to 10. All that demonstrates is that you know what the condition is. It doesn't demonstrate that you checked it. So you need to show that you've actually done the math and checked it. So both of those are bigger than 10. The independent. Since you're sampling without replacement, we're going to check the 10% conditions, so it seems reasonable that there's at least 5,000 potatoes in the shipment. Alright, the next step was the do. So you can calculate the test statistic. So there's the p hat minus the p naught. And then just note in the hypothesis test you're using the p naught. There's the test statistic. And then you can find the p-value using the table or the normal CDF. What I allowed you to do in class was I allowed you to use the calculator command, and you are still allowed to do that. You just need to make sure that you're actually writing down what the inputs are. So if I go to stat, I go over to tests. I'm doing a hypothesis test for the proportion, so I'm going to pick number 5. The p naught is 0.08. That's what was in the hypotheses. The p hat, so that's 47 was the x, so that's how many potatoes had blemishes. It was out of a total of 500. The direction of my alternative hypothesis was greater than. So I'm going to select this one, and then I'm just going to hit calculate. Alright, and then I'm going to get the test statistic of 1.15, and there's my p-value. So like I told you to do, write down what you typed in for x, write down what you typed in for n, write down which direction that you picked. Alright, so I got a similar result as they did. I'm slightly more accurate because I used the calculator. And then I would just compare. My p-value is greater than the significance level, so I'm going to fail to reject, so there's not enough evidence to conclude the shipment contains more than 8% of the blemished potatoes. This extra sentence I just kind of added. You don't really need to do that. Here's another example. This is just a two-tailed one. Everything is kind of the same idea here. I'll leave the screen here for a few seconds if you want to pause it and read through it. They find the test statistic by hand, then they find the p-value by hand. Again, if you're using the calculator, the only thing that you're going to change when you do that test these things would change based on the problem, and then you'd just be selecting the not equal to. But then the calculator will give you your two-tailed p-value. And then the way that you write your conclusion, again, that's less than the chosen significance level. There is enough evidence to reject and conclude that, and you're just concluding in the terms of the alternative. Another thing that you can, we talked about is just how we can use a confidence interval to compare a two-sided test. So what you can do is you can create the confidence interval, and if your stated the number in your hypotheses is in that interval, then you would fail to reject. And I'll leave this up here for a few seconds if you want to read it. But the big idea from that is basically that confidence intervals just give you some more information that significant tests do not, because the confidence interval gives you a range of variable values, whereas a significant test just tells you yes or no. And again, if the p naught, or that number, is inside the interval, then you're failing to reject because it's a plausible value. If it's outside the interval, then you're rejecting. Alright, and then lastly, let's quickly look through this one. We'll kind of do it the same way. So when we're talking about a mean, we did talk really quickly about how you could use the z-distribution, but I'm going to skip over that. We went through and we went straight into the t-distribution because we didn't have the population standard deviation. I'm just going to find the example here. Just to remember with the t-distribution, the normal condition, either the population has to be normal or the sample size is large. We also had to check that we could also make a graph of it and check to see if it was normal if it was under 30. And the population still has to be 10 times the sample. Alright, let's look at this one here. So we're still going to go through those 4 steps. So they want to know if the amount of the DO levels are below 5 milligrams per liter. So there's 2 hypotheses. The mean is that it doesn't give a significance level in the problem, so they're just stating that they're going to test it at the 0.05. So you are perfectly fine in doing that. They're going to do a 1-sample t-test for the mean. The researcher did it at random locations. Alright, the normal. So here's the thing about the normal. It doesn't say that the population is normal. The sample is not bigger than 30, so they're going to look at a graph. You don't need to look at all 3 of the graphs. Just look at one and state that you looked at it and you don't see any major skew or any outliers, so you're safe to use the T procedure. Draw a sketch of your graph. So again, I would just have you say, like, here, if you just want to do the histogram, you could say the histogram looks roughly symmetric. If you were doing the box plot, so the box plot has no outliers or skews. If you looked at the normal probability plot, the normal probability plot is fairly linear. Again, so the conclusion here is since there's no outliers or strong skewness, we can use the T procedure. Alright, there's the independent. Alright, it says here that there's infinite number of possible locations on the stream, so it isn't necessary to check the 10% condition. All that's saying is if you went through and you said that there's at least 150 locations, I don't think they would mark you wrong, but the point here is being that you're almost, it's not, you are sampling without replacement. You're not putting that spot back. However, there's so many spots along the stream that it doesn't really matter because the population is like infinite. Alright, so then you can go through, find your test statistic, find your p-value. What I had you do, if you're finding the p-value by hand, is using the TCDF. Remember the TCDF command was lower bound, upper bound, comma, the degrees of freedom. And the degrees of freedom for the t-distribution for this test are n minus 1. So what I would have had you do for this one is I would have had you go to stat. We would have gone over to tests. And we would have used number 2, the t-test. We would have used the, you could have used the data option, so you could have typed everything into a list. I'm going to just use the stat option just because I don't have everything typed into the list. The 5 was in the hypotheses. The sample mean was 4.771. Oops. The standard deviation was 0.9365 or 96. Oh my goodness. The sample size is 15, and the hypothesis was less than, well, and then, sorry, I hit delete. The hypothesis was less than, so I would have picked that, and then I would have hit calculate. So I would have came up with the same test statistic as them. I would have gotten my p-value. I'm going to get a slightly better p-value just because I'm not using the table. Again, since the p-value is greater than alpha, I'm going to fail to reject, and there's not enough evidence to conclude that the DO level in the stream is less than 5 milligrams per liter. And then since I failed to reject, it's possible I made a type 2 error. I couldn't have made a type 1 because I didn't reject. We can also do two-sided tests. So you can kind of go through and look at this if you want. I'll leave it up here for a second. Again, I would have done the same thing on the calculator. I just would have done not equal to. And then just like before, we can figure out from a confidence interval that there's a link. So if the number in the null hypothesis is inside the interval, you're failing to reject. If it's outside the interval, you're rejecting. You can read through this if you want to. We also talked about something called pair procedures, and I will do that in a separate video.